Hello everyone. So for today, I will be teaching you on how to calculate reacting masses. The steps to success are to find the relative atomic masses of elements present in the chemical formula from your periodic table. Next, you must be able to calculate the MR for the elements or and compounds stated in the chemical equation. Next, you need to be able to make ratio between two known masses. Later, you need to be able to cross multiply to find out the unknown mass of the reactant or product. Okay, let's begin with example 1. Carbon dioxide reacts with carbon to produce carbon monoxide. The equation for the reaction is this. Okay, so part A, the relative molecular mass of carbon dioxide is 44. So where is our carbon dioxide? From your previous lessons, you have learned carbon is followed by the letter C. Di means 2 and followed by oxide is from the oxygen's name. So the formula for carbon dioxide should be this. Okay, so take note here, CO2. And then here at the bottom, you notice that they give you the AR. The AR here for oxygen is 16. How to read? The letter and the number next to it is the pair. Okay, so carbon is 12. You can double check at your periodic table once again. Part 1 here, calculate the relative molecular mass of carbon monoxide. So which one is carbon monoxide? So here you have carbon. Mono means 1, oxide is from oxygen's name, so is O. How do I know and where to get it? It is already being stated here. Okay, you can see the statement already from the first line. They give you this carbon monoxide. Shall we include the 2? The proper answer is no, because all that you have done for relative molecular mass, you don't need to include the 2 in front. Okay, so bear in mind. So where to get, how to calculate? So carbon is 12 plus with 16, so you get 28. So that's all for part 1. Next, part 2, complete the following sentences. So the first line here, 44 gram of carbon dioxide produce blank gram of carbon monoxide. Okay, so let's write it down. CO2, carbon monoxide is CO. Okay, so how are you going to calculate the missing mass? So first thing first, you have to check on this step to success. The third one, make a ratio between two known masses. So these two known masses are carbon dioxide and carbon monoxide. So let's write it down. Carbon dioxide is CO2 to the ratio of carbon monoxide. For this case, you have to include that number in front, which is 2. We call this the coefficient, so we have to put the 2CO. Okay, so next you need to be able to put down the MR. I forgot to put down the MR, yeah, which is here from this point number 2. Calculate the MR. Okay, so we make a table here so you can see better. So what is the MR for carbon dioxide? Let's check the question again. Actually, they give you here already. The relative molecular mass for carbon dioxide is 44. So you don't need to calculate it actually. Okay, just write it down there. Next, carbon monoxide. Where's our relative molecular mass for carbon monoxide? So for carbon monoxide, the CO is only 28. Since we have 2 CO, it means we have to multiply 2. 2 times 28, which give you 56. Okay, so actually the ratio is 44 to the ratio of 56. So let's read the question again. 44 gram of carbon dioxide produce how many gram of carbon monoxide? So since the ratio already stated that it is 44 gram of carbon dioxide, so definitely it will give you 56 gram of carbon monoxide. So we can safely write down there, it is 56 gram of carbon monoxide. Okay, next, the second line here, the last one. What about 1.1 gram of carbon dioxide? will produce how many gram of carbon monoxide. Okay, how are we going to calculate this? Since we have the fixed ratio here, it is 44 to the ratio of 56. So now we're gonna put in the known one. Known one, where do we put at? Carbon dioxide. Must put underneath the same column, alright? So it is 1.1. How many gram of carbon monoxide? You don't know, so you put an X. So what we're gonna do? Cross multiply. This cross with this, this cross with this. Everybody knows how to do cross multiply. Let me teach you how. Okay, this X brings to the 44, then you should get 44 times X. Okay, this 1.1 multiply with 56. Okay, 1.1 multiply with 56. Next, you need to make X as a subject, so you have to move this 44 to the other side, which will become division. Okay, 1.1 times 556 divide with 44. Okay, get your calculator and be ready to calculate for this. Okay, you should get 0.14. Okay, 0.14. So basically that's how to solve question number 1, example 1. Alright, now I will give you another example, question number 2, example number 2. Alright, so here we have potassium burns in oxygen to form potassium oxide. Okay, so we zoom in and see the chemical equation is given, and here the AR, atomic mass, you are given with potassium. Okay, you don't know what is the letter K, go back to your periodic table and read it. Okay, here we have oxygen, oxygen is 16. Okay, A part 1, you are required to calculate the relative molecular mass MR of potassium oxide. So where's our potassium oxide? Potassium, you know, is K, oxide is from the name of oxygen, so the only formula that resonates is this. Okay, but do you need to include the 2? No. Okay, when they ask for relative molecular mass, is only asked for 1. Okay, only 1. So only K2O only. Alright, so for this part, ignore the 2 in front. Ignore the 2 in front, just focus like this. Okay, so let's calculate. So begin with potassium. Potassium's mass is 39, right? So 39, so there's 2 of potassium, multiply with 2, we put a bracket just to be safe, and then plus with oxygen. Oxygen is 16. How much is that? Get your calculator out and calculate the numbers. Okay, you get 94. Okay, so that's done for part 1. Part 2 here, complete the following sentences. Okay, when you have this, it means you have to do ratio. Alright, so for 78 gram of potassium reacts with blank gram of oxygen. Okay, so focus on this first. Focus on this first. Alright, so you have potassium 4K, oxygen here, this is the oxygen 2O2. Okay, so you make the ratio first, 4K to the ratio of O2. Alright, first thing, MR. What is the MR for 4 of potassium? Okay, so if you read it, it will be 4 of potassium, so it means 4 times 39. Okay, 4 times 39, you get 156. Next, you have oxygen. Oxygen, there's a tiny 2 here, so it means you need to multiply also. So it means 16 multiply with 2, you get 32. Okay, so it means that we have the ratio 156 to the ratio of 32. Alright, now we have 78 gram of potassium. So where shall we put our 78? So 78 will be underneath potassium here on the left side. So how much oxygen is needed? You don't know, you put an X. Okay, you don't know. So next you need to cross multiply only focus this number. Alright, this. Alright, so you just multiply. So x multiply with 156, you will get something like this. Multiply with 78 times 32. Okay, 156 bring to other side, become division. 78 times 32 divide with 156, you shall get okay, you get 16. So it's 16 gram of oxygen. Is that okay so far? If you are confused or couldn't get it, you can rewind this video. Okay, alright, next the second part here, and produce blank gram of potassium oxide. Okay, how are we going to calculate this? Okay, so next we are still using this also, this ratio. Okay, but we have to change something. Okay, so this time we still need the 4 of potassium. Okay, because the beginning line starts with potassium, is 4K to the ratio of potassium oxide. Where's our potassium oxide? This. Okay, 2K2O. So we write here 2K2O. Alright, so same thing again as the example here. You need to do the MR. Okay, MR. So MR for 4 of potassium is this. Okay, 156. You don't need to calculate again, it's the same number. Okay, of course it's the same, I don't need to calculate. But what about this? This one, let me check again. So we have potassium oxide, right? We already calculated on the first part. We can just get this number. But bear in mind, this is only for 1. Okay, 1 potassium oxide. Here in the question, in the equation, you can see there is 2. Okay, let me erase and then let me properly see. Okay, 2. So it means you need to multiply 2. 2 times 94. So let me copy it again. 2 times 94, you should get 188. Okay, 188. Okay, wait, let me enlarge this. Alright, so what if you have 78 gram of potassium? So 78 gram to the ratio of how many potassium oxide? So it means you cross multiply. Same thing as well. Okay, same thing. 156 multiply with x. 188 multiply with 78. Okay, x is equal to 188 times 78 divided with 156. Then you should get 94. Okay, so 94 is here. Alright, so last one. Here we have 3.9 gram of potassium gives or produce blank gram of potassium oxide. So how much is it? Okay, how are we going to create this ratio? So potassium is the same 4K, potassium oxide is the 2K2O, right? So it's means we're still using this ratio. What I will do is I will still use the same one. Okay, let me rewrite it here. 4K to the ratio of 2K2O. Okay, first row is MR always. Okay, as you remember, the value here for 4K is 156 to the ratio of 2 of potassium oxide. Potassium oxide here, 2 times 94, you get 188. Okay. Okay, next you have 3.9 gram of potassium. You put it here, 3.9 gram. How much of potassium oxide you get? Again, you cross multiply. Okay, take your calculator out. you may know already how to cross multiply. Okay, so 156 times x equal to 3.9 times 188. X is equal to 3.9 times 188 divide with 156. Okay, so calculate this. So the answer you should get is 4.7. Okay, so the answer is 4.7. So are you okay so far? Okay, you have to try it yourself. Get a piece of paper and attempt it while you listen with me. Okay, so you may screenshot this and then take a moment to understand this by yourself. All right, if anything, we'll discuss this in the class, but now I would like you to try this. Okay, test it yourself. So screenshot this. Okay, I'll give you a Google form for you to answer, and we shall discuss this in the class. Okay, but before I go, let me just clarify you something. Okay, so which one is iron 3 oxide? Okay, iron 3 oxide is this. Okay, Fe2O3. Which one is aluminium? Aluminium is this. Okay, Al. Which one is iron? Iron is this, Fe. Okay, so I hope by now you should be understanding how to calculate all this. Okay, I shall see you soon. Thank you for listening.